Every time you learn something, you change your brain. Every time you have a new experience, you change your brain. How does that brain rewiring work? Well, it turns out there's two processes. And we're talking about the two types of consolidation, where you take something new, a new memory, and you really get it solid or into your brain. The first one is synaptic consolidation, and what I mean by that is there's processes that happen at the level of a synapse that enable you to rewire your brain, to change your brain because you've learned something or experienced something. Synaptic consolidation happens at the synapse, and it can happen very quickly, in minutes to hours. Systems consolidation is a much bigger and slower way of rewiring your brain. You're reorganizing the neural network itself. And systems consolidation is a sort of consolidation process that takes up to years, right? Months to years, where you're literally physically changing not the biochemistry, but the interconnectedness of your brain. Let's start first talking about synaptic consolidation, and I can't mention synaptic consolidation without talking about this professor, Hebb. And Hebb is known by all students for what's known as the Hebbian rule. And it's a very simple way of talking about how your brain rewires. The Hebbian rule says that if cells fire together, if they respond at the same time, then they wire together. They start connecting with each other. So the Hebbian rule, which I guarantee I will ask you about, is cells that fire together, wire together. And that's a central principle for Hebb's research in trying to understand how the brain changes as you learn and develop new memories. What do I mean by that? Let's imagine you have two neurons and there's a synapse between them. If they're being activated together over and over and over again, they are going to learn how to talk to each other more effectively. Sort of a bigger bang for your buck idea. Here's a larger drawing of it. We've got two neurons, right? The presynaptic, so the sending neuron on top, and the postsynaptic, the receiving neuron on the bottom. And let's say that at the beginning, when the first neuron releases neurotransmitter, then the second neuron is able to receive it in the following ways. But what I want you to do is to see on the far right those same neurons after they've been stimulated repeatedly over and over again. What I want you to see is that the first neuron is releasing more neurotransmitter, and the second neuron now has more receptors. That's synaptic consolidation. What's happening in the synapse is changing because cells that are active together a lot learn to talk more efficiently, learn to have a bigger impact on one another, and they do that by increasing the amount of neurotransmitter that gets sent into the synapse, and also increasing the number of receptors, or the responsiveness of the receptors in the receiving neuron. Now, there is another phrase for this. It's called long-term potentiation. LTP, long-term potentiation, refers to the structural changes that take place in your synapse when you learn something new or have some new experience. So, to say it again, long-term potentiation is how connections between neurons change when there's repeated stimulation, when you learn something new. So the sending neuron is going to start sending more neurotransmitter, and the receiving neuron is going to start growing or developing more receptors to receive that neurotransmitter. Now, there's also the opposite. Let's say you've learned something like, I used to know French, I spent a lot of time studying it, but I haven't spoken French in 20 years. So I've lost a lot of my French. That's another kind of rewiring, but now I've lost something. How do we understand the loss of memories? long-term depression. And I don't mean sadness. Long-term depression is the opposite of long-term potentiation. Long-term depression is when the connections between new neurons weakens. The sending neuron sends less neurotransmitter, and the receiving neuron allows some of the receptors for that neurotransmitter to die off. So it's the reverse. The two neurons are communicating less effectively. They're sort of, you can think of it as starting to ignore each other, or not responding as much to one another. That's all I'm going to tell you about synaptic consolidation. Next, we're going to talk more about systems consolidation, especially as it applies to the hippocampus.